Hey folks, today's lesson is a bit of a, what's the word, loose end maybe? So the main path of the class from here on out is we're about to get started on understanding what a function is. It's a process that you do to a number. We represent them with letters, but they're not like variables. They're one of the main themes of this class, one of the main tools that we'll use. But before we do that, there are a handful of other kinds of things you can solve, like equations to solve, and then we'll deal with what happens if it's an inequality sign and not an equal sign in 2.7. So this lesson is the first of those two lessons. It's where we're just going to see really a smorgasbord of other kinds of equations that we could solve. So I just want to show you, it's kind of an eclectic mix of different equation solving techniques. So let's go ahead and get started with this one. 4x cubed plus 12x squared minus 9x minus 27 equals 0. And so the reason I'm showing this one, this is a technique that I skipped earlier, but I thought it'd be nice to see it. It's called factor by grouping. And it's nice for certain cubic equations. It doesn't have really broad applications, but it's nice once in a while. And this is one of those times. So what we're going to do is, there's no greatest common factor here we can work with. We don't really have much of a hope of solving this normally because it's a cubic and we only have quadratic methods. But what we can do is say, let's factor these two terms and these two terms separately and see what happens. So with the 4x cubed plus the 12x squared, now there's a greatest common factor I can take out. Do you see what it is? Both of these terms are divisible by 4x squared. 4x cubed over 4x squared is just x. 4x squared times 3 would make 12x squared. So I can pull out a 4x squared and get x plus 3. Now this second pair of terms, negative 9x and negative 27, watch what happens. If I pull out a greatest common factor of negative 9, then the first one, of course, is just x, and 3, come on, update, 3 times negative 9 is negative 27. So look at that. I've got 4x squared minus 9, and each term is multiplied by x plus 3. So if you're very lucky, this is what will happen when you factor by grouping. This x plus 3 and this x plus 3 are the same. So think of it this way. This is a little bit tricky to conceptualize the first time. If I had, let's say it was just 4a and then I wanted to subtract 9a, I could write that as 4 minus 9 times a, right? I can factor out the a. So I can say we have 4 of them minus 9 of them, so we're going to have negative 5 of them. That makes sense? So down here, I have 4x squared. Think of this x plus 3 is like what I'm calling a. This whole expression. I have 4x squared of them here, and I'm taking away 9 of them here. So altogether, I should have 4x squared minus 9 of them. I should have 4x squared minus 9 copies of this thing. Oh, Google Meet is really slow today. I should have 4x squared minus 9 copies of this x plus 3. So we were able to factor this cubic into a quadratic and a linear, because 2 plus 1 is 3. We were able to factor it by treating each pair of terms separately and then seeing how they come together. This doesn't work for every cubic. It doesn't even work for most cubics, but it's a nice enough technique that when it does work, it's nice to notice it. Now we can factor this one more. We can go one step further. When we're factoring, our ultimate goal, and it's not always possible, but our ultimate goal is to get down to just linear factors. So just things like this. This is a quadratic factor. This is a linear factor, because x is to the first power here, but x is to the second power here. So do you see? It's my one of my favorite factoring formulas right here. This is a difference of squares, because 4x, or 4x squared, is the same as 2x squared. That's easier to see written than in English, but do you see what I mean? 2x times 2x, well, 2 times 2 is 4, x times x is x squared. And then, of course, 9 is 3 squared. And since I know that a squared minus b squared equals a plus b times a minus b, that's the difference of squares formula, I can factor 4x squared minus 9 as 2x plus 3 times 2x minus 3. So there you go. We've turned this cubic into 3 linear factors. And that's about as good as we were ever able to get. Now, factor by grouping is also really handy in cases where you would normally have to slide and divide. Now, I like slide and divide better. I think slide and divide is actually easier, but it might be useful to know how it is that we can treat that with factor by grouping instead. So let me find an example here. 2.3. Where did I put that? 2.3, 2.2. Oh, they're in this notebook. Hold on just one moment while I pull up an example. Polynomial factoring, here we go. All right, let's say 6x squared plus 5x minus 4. Now, before I showed you, we could slide and divide this thing. So we could say there's a new polynomial, x squared plus 5x minus 24. And I can factor that as x plus 8 times x minus 3. Then I divide both of those by the original leading coefficient, 6. And that makes x plus 4/3, x minus 1/2. And to make these the factors of the original, we slide those denominators back up and make 3x plus 4 times 2x minus 1. So that's the slide and divide way, and honestly that's the way I prefer, but I just wanted to show you that it is also possible to do this by factoring by grouping. Now I know in factor by grouping I had 4 terms and I split them up 2 and 2. Well, that's actually what we're going to do here. See, this 8 and this 3 have a dual purpose here. I want to show you how factor by grouping corresponds to slide and divide here. If I write 6x squared plus 5x minus 4, if I take that 8 and 3 that I found when I was doing slide and divide, I could say this is 6x squared plus 8x. Is this going to give me what I want? Yeah. 6x squared plus 8x minus 3x minus 4. See? 5x is the same as 8x minus 3x. So it's this 8 and this 3. They multiply to get 24, and they add up to get 5. So they are what I want. Now, if I treat these as 2 groups, I can say 6x squared plus 8x. Well, what's our common... I forgot the word. Our common factor there. I could pull a 2x out of each of those. So, and if I pull out a 2x, 6x squared goes down to 3x. 2x times 3x is 6x squared. And 2x times 4 is 8x. So I get a factor of 3x plus 4. And then if I pull out a factor of -1 from this second pair, I get another 3x plus 4. I chose to pull out -1 instead of +1, so I would get 3x plus 4 instead of -3x minus 4. That way these two factors match, and I can say I have 2x of them here and -1 of them here. So altogether I have 2x minus 1 of them. 2x minus 1 copies of 3x plus 4. Now, since the order of multiplication, of course, doesn't matter, I've got the same pair of factors here that I do over there. 2x minus 1 and 3x plus 4. So that's 2 different ways to get this same answer. Like I said, slide and divide it's easier for me. If this way makes more sense to you, then by all means do it this way. But maybe you see how slide and divide corresponds to these steps. We do the 8 and the 3, pull those out, and somehow we get the same factors here that we got here. So 2 different ways to solve polynomials like this. Use whichever one makes more sense to you. Just for fun, let's do another example. How about 5x squared plus 7x minus 6. In the slide and divide method, I would slide the 5 down to the constant term and make x squared plus 7x, and then negative 6 times 5 is minus 30. So I'm looking for 2 numbers. In either case, I'm looking for 2 numbers that multiply to negative 30 and add up to 7. Well, that's not a tall order. That's just x plus 10 and x minus 3. Then I divide by my original 5, my original leading coefficient. And so this one looks like x plus 2, and this one looks like x minus 3/5. And then we just slide that denominator back on up to the front. So this stays x plus 2, but this one becomes 5x minus 3. And that feels a little magical, but it's also pretty easy, and it produces the right answer. Over here, again, I ask, what multiplies to 5 times negative 6? So what multiplies to negative 30 and adds up to 7? Again, the answer is 10 and 3. So this time I'm going to make 5x squared plus 10x minus 3x minus 6, and ask, what are the common denominators of the first 2 terms and the second 2 terms? So for the first 2 terms, my common denominator is 5x, and that leaves me with x plus 2. Because 5x times x is 5x squared, 5x times 2 is 10x. Second pair of terms, I get a negative 3, and when I pull that out, I get x plus 2. And then I have 5x, x plus 2's here, and negative 3x plus 2's there. So altogether, I have 5x minus 3 copies of x plus 2. You will always get the same answer with these 2 methods. So again, whichever method makes more sense to you, use that method, whichever method is more comfortable for you. Of course, if that method is the quadratic formula, then by all means do that. But I think that the quadratic formula, when the problem actually does factor, like it does here or here, this is a little bit faster than the quadratic formula. But the nice thing about the quadratic formula is it works even if the problem doesn't factor. So use whichever method you like. I'm not picky. Let's see something a little different. What if I had, where was my, well, I've lost my page now, haven't I? Here we go. What if I had something like this? What if I told you that x to the 4th plus 11x squared minus 12 equals 0? Actually, you know what? I don't like this one so much. Let me do a different one first. I'll come back and do that one next. Let's say I had 3x minus 7 squared plus 4 times 3x minus 7. How about plus 3 equals 0? Okay, this is a great first one. So this is a tough equation to solve. I'll show you a first method, and then we're going to abandon that approach and use something more practical. So we're only going to go a couple of steps into this, but method 1, in math, I like to call this brute force, where we see the problem, we see, okay, I know a straightforward, painfully difficult way to solve the problem, and I'm going to plow full steam ahead without trying to think of anything more elegant. So of course, in this case, brute force is simplify this and then use whatever method works. So brute force would look like, okay, I'll FOIL this, 3x minus 7 squared. So 3x times 3x is 9x squared minus 7 times 3x. So that'll be negative 21x. We'll have 2 copies of those inside and outside. So we'll have negative 42x. Last, negative 7 times negative 7 is a plus 49. That's the first three terms. Next, I distribute the 4 to 3x minus 7. So 4 times 3x is 12x. 4 times negative 7 is negative 28. And last, I have a plus 3. Next, I gather like terms. So I have 9x squared, 42x, negative 42x, and a plus 12x, so minus 30x. And then 49 minus 28 is 21, plus 3 is 24. This is a stinker. This is a big stinker. This is a difficult slide and divide problem, or factor by grouping, whichever one you prefer. I'm looking for two numbers that multiply to 9 times 24 and add up to 30. Oh boy. What two numbers would work here? So let's see, 9 times 24, that's, oh boy, that's 3 times 3 times 3 times 2 times 2 times 2. 9 times 24, and that's 216, which is 2 times 2 times 2 times 3 times 3 times 3. Just save you the time of doing the factor tree. I did that one in my head. I need them to add up to 30. How about, no, 36 and 6 is too much. Oh, wait, 36 and 6. What if nope, wrong sign. If this were a plus 30, that would work. Or if this were a minus 24, rather. So let's see, how about 8 and 27? No. Do I have this written down somewhere? How about 4 and 54? No, that's way too big. How about 24 and 9? No, that's what I started with. Well, look, you see that this is going to take a while. I might even end up using quadratic formula. But we could finish the problem and get our solutions. Tell you what, let's come back to method 1 because it stinks. And let's take a look at method 2. I'm going to call this substitution. Now take a look. If I were trying to solve x squared plus 4x plus 3, it would be very easy. I could write it as x plus 1 times x plus 3. And then I could get my solutions. Do you see what the original equation has in common? It's got a thing squared plus 4 of the thing plus 3. If only that thing were a single variable, right? Just this here. Let me copy this down here. Tap, copy, tap, tap. Paste. Yeah, there we go. All right. So what I'm going to do is I'm going to treat the thing like a single variable. I'm just going to call this thing y. We're going to say let y be 3x minus 7. I'm going to use my little colon equals because this is a definition. So let y be defined as 3x minus 7. Then this equation just looks like y squared plus 4 times y plus 3 equals 0. And I know how to factor this. I factor it as y plus 1 times y plus 3 equals 0, no problem. So then y equals negative 1 or y equals negative 3. Because negative 1 would make this factor 0, negative 3 would make this factor 0. This is a zero product property again. So that's really easy. That's really chill. Just y is negative 1 or y equals negative 3. And now to finish the problem, I need to find out what x is. So y was 3x minus 7. So this would say either 3x minus 7 equals negative 1 or 3x minus 7 equals negative 3. Now I add 7 to both sides. 3x equals 6, so x equals 2. I add 7 to both sides. 3x equals 4, so x equals 4/3. Think that's right. Yep, yeah, that's right. Okay. So Now that I know that these are my factors, I can cheat and head back up to the brute force and say, since I got 3x equals 6 here and the factor of 3 came out, that's a raging clue that a factor of 3 comes out up here. So what I didn't see before was the reason I was having so much trouble is I can pull out a GCF, 3x squared minus 10x plus 8. And now that's a little easier. Specifically, I know from down below that it factors into x plus 2 times, plus 2, no, minus 2, has to be minus 2. Come on, update. This would give me x minus 2, and this would give me a 3x minus 4. So I'm going to copy those up here. X minus 2 and 3x minus 4. You can FOIL those and check. Negative 2 times negative 4 is positive 8. Minus 6x inside and minus 4x outside to give me negative 10x, and x times 3x gives me 3x squared. So there's our solution up here. There, that's not so bad after all, but I wasn't going to see it on my own. I got stuck. So instead, I went ahead with the much more clean, elegant solution of solving the easy problem first and then the hard problem. So if you can break the problem into 2 parts, first let's just solve y squared plus 4y plus 3, and then we'll worry about the 3x minus 7 after. It's a lot easier than trying to solve it all at once. So that's the substitution method. I think it's a really neat way to solve equations like this. And now that you've seen that, I bet you have a much better idea of what to do with x to the 4th plus 11x squared minus 12 equals 0, right? Man, this would look so much simpler. Wait a minute, what the heck are the factors? Oh, duh. Okay, this would look so much simpler if it were, if we let y be x squared, because keep in mind that y squared equals x squared squared, which is x to the 4th. So we're going to let y equal x squared. And that means that y squared will be x to the 4th. So I can rewrite this equation as y squared plus 11y minus 12 equals 0, which I know what to do with. That's y plus 12 times y minus 1 equals 0. So y equals 1 or y equals negative 12. First part's easy. Second part, I don't want solutions for y, I want solutions for x. So x squared equals 1 or x squared equals negative 12. So x equals positive or negative the square root of 1, which is 1, or x equals positive or negative the square root of negative 12. So x equals 1 or x equals negative 1 or x equals, what is that? 2 root 3i or x equals negative 2 root 3i. Do you see why that's 2 root 3i? Just as a refresher, root negative 12 is the same as root 4, root 3, root negative 1. Product property, I can split this square root up into factors any way I like. And what I like is this, because that gives me root 4 is 2, root 3 stays, root negative 1 is I. So that's where I'm getting that number. All right, so substitution got us the solution. Substitution is a pretty handy tool for solving equations that we couldn't otherwise tackle. Okay. Tell you what, that's a pretty good breaking point. Let's stop this video here, and the second video for section 2.6 will cover absolute value. See you soon.